When we have flat samples, it's always easy to focus on them. But when the samples have height differences, what is the depth of field, so focus area, that we have and which gives good enough results in our sorting? Let's look at the equation. In industrial applications, the sample thicknesses may vary, so we may have different thicknesses which we should be able to classify and sort. We are talking about depth of field. That's the distance between the nearest and farthest object that are still in acceptable focus. When we calculate the depth of field, we need to know the focal length of our lens. We need to know what is the distance from the camera to the surface or conveyor belt. We need to know the lens F number, and then we have the parameters that are called circle of confusion, which I explain in my next slide. Anyway, to calculate these, the equations are in the right side. I would not start calculating this by hand. I usually Google and find a depth of field calculator online. There is a link for one of those, and I use those calculators instead of my own calculator. Now, what is circle of confusion? Circle of confusion refers to an image that is acceptably sharp. And in digital imaging, where we have discrete pixel sampling, we usually take the pixel size. And taking the Nyquist criteria, we can assume that if the optics is good enough, our front objective and the lenses, then the image quality is good if our circle of confusion is about 2 to 3 times the pixel size. And in practice, when we take FX10 or FX17, where the standard objectives have 15 and 17 millimeter focal lengths, f number 2.1, I am using a circle of confusion of 0.035 millimeters. And using this and the calculator, the previous calculator, I get that, for example, 0.1 meter distance, the depth of field is approximately 10 to 12 centimeters. From 1 meter distance, depth of field is about 50 centimeters. And when I focus to the surface, I don't focus to the conveyor belt surface, but I take the sample thicknesses and I put my best focus on the mean of the sample thickness. When the sample thicknesses are different, one should also think about how to make the illumination so that the samples that are more thick also get enough illumination on the surface for good measurement.